Okay, I realize it's starting to be the end of the day, so hopefully people aren't too tired. But this is kind of the last presentation, and this is traditionally part of the FLUG user group meeting where we want input from the users. To give it a little bit more context, I've put some slides that I gave in a webinar some time ago. Where I show some new functionality in the most recent version of FLACS, so FLACS version 10.4. So I'll show that first, just go through some of the new features we have, and hopefully that will give a nice kind of context to give more feedback to us. Yeah, so this typically, I mean, you can discuss things that are your new features that you would really like, or things that you're struggling with in the existing version. So it's really, this part is really about you here. For the people who don't use FLACS, well, I guess you will see a little bit on all the things that we're working on in the most recent version. And yeah, you might have some questions also that are relevant. One thing, the presentation by Lloyd's Register raised the issue of geometry, the accuracy of geometry, and an industry consensus. I just want to say that we have quite a big team who actually build FLACS geometries, both in Norway and in this region. So if anybody has, I don't know, especially when you're just starting to use FLACS, building an accurate geometry for explosions is sometimes a bit challenging. So I want to say that we offer kind of consulting services to help you with geometry work, so you can outsource that to us, for example. And we also provide training courses to teach you how to actually build a geometry accurately. So if anybody's interested in that, I don't know who to contact, but probably Ben or Eric or FLACS@Gexcon.com, and then we can see if we can help you with that. Right, let's. Yeah, so this is. For those who really, I mean, some of you might have already participated in this webinar, and then it's maybe a bit boring, but for the others, this is just going through some of the new features we have in the new version of FLACS 10.4. So this is the version that was released probably 2-3 months ago. And then I'll also briefly touch on a new version that's coming out in probably about a month, or like a few weeks, which we call a bug fix release, and it kind of we just address some minor issues, not necessarily bugs, but some minor tweaks. So we don't change the whole model. And then finally, we'll end with the kind of FLACS user group discussion and wishes, etc. I'll just hang on. Yeah, just a summary of some of the new stuff we have in the new version. So one of the things is a multi-selection and quick filter in the object window. So for all these, I'll just show you like videos on things, how this works, but this is just a quick summary. We added AutoCAD 3D import. So before we just had MicroStation import, and now you can also import AutoCAD files. We've improved PowerCalc. We've added minimum, maximum, and impulse quantities to all 3D data. We have a new leak type for entrainment. Yeah, I'll just give a summary of some of the FLACS fire improvements we added. Yeah, and then a bit about Python API and the streamlines are really nice, so that will be good. And this is all videos, so it's a little bit interactive. And I'll just start this. So this is, yeah, this helps you model. We were talking about geometry. This helps you select objects in your geometry. I'll just start the video. So this is your normal geometry. And this will help you select objects of a certain size or certain properties. So here I'm pressing Control, and then it's really easy to quickly select objects. So like you're used in Excel or those kind of programs. And then once you've selected those, you can do stuff. So you can move it. So yeah, it's. For like manipulating your geometry, this is really easy to use. You can also like use a selection filter. Okay, now I'm just using a bounding box with Shift. So there we go. So here I'm using. It's hard to see, but I'm using a quick filter. where you can say, I want a cylinder of a certain size, and then it selects all those objects. That's what you see here. And then you can also use negative filtering, and it's hard to see what it's doing. So, yeah, so this just helps you modify the geometry really quickly. And then again, you can do the same. You can move it, you can delete it, you can do stuff to it. Just skip to the next. We've also improved geometry importing, and that's one of the things we'll also address in the new version. You can here see the difference between 10.3 and 10.4. As you can see, there's a little bit more detail we have in the import. So improve the models when you import models. I won't say too much about that. This is just a demo because some people are asking, like, how do I import AutoCAD files? Well, it works exactly the same as importing DGN files. Oh. Just, where's the mouse? There we go. So just show, so this is now an example importing an AutoCAD file. So here we go to the directory, that's an AutoCAD file, DWG. And then for the rest, everything is the same. And you press OK, and it imports the model. This is a really simplistic, now you can see, visualize the model. So it works exactly the same as importing MicroStation files. Yeah, it's not terribly exciting, this model, but the same works for larger models. These are just a pair of stairs. Yeah, so we addressed some issues in the geometry import. So we fixed slow import. Oh, yes. So this is the things we're fixing in the bug fix is coming soon. So slower imports, some stability issues with some geometries, and a crash when the object name in a DWG file is very large. So some of this we'll fix in the bug fix. We've also made a minor tweak to the default setting in the leak wizard. So this doesn't change the modeling at all. It's just a change of defaults. And these are the new defaults. And what that does is that if you have, it's like especially these kind of cases where, yeah, you want to have very long releases. So for example, 1,000 seconds. Then before it would cut it off here. And then now it just models it like this. So before, if you change this manually, you can get the same, but the defaults are now a bit more robust. So it doesn't change the actual modeling in FLACS, just the inputs, the time-dependent leak input. And this is, we did some minor tweaks to PoreCalc, and this just shows a scatter graph with the old version, new version, and you can see that in generally the overpressures are a little bit higher. This is quite nice. This is now that for every single 3D variable, you can use maximum or minimum or impulse. So impulse is the integrated variable. And this is really good. Like before you had this only for overpressure, so Pmax. Now you have this for everything. So in this example, I'll show Fmol max. So maximum concentration in every cell. And so it works the same as Pmax, but now for concentration. Some of these are included in the menu. So here you can see Fmol max. The ones that aren't included, so we've only included the most common ones. The ones that aren't included, you need to manually edit the CS file to add those. Yeah, most of those won't be used that much. That's why I haven't included them, to not clutter the interface. Just show how this is just showing the difference. Is it? No, it's not playing. So here we have normal concentration, and here we have Fmol max. And then you can see that all the kind of meandering is removed because it just shows the maximum values. We also have a new entrainment model. This is really nice. And the purpose of this is to speed up dispersion simulations. So this is a normal leak. This is normally how you do a leak in FLACS. So you have a high pressure reservoir. You have you have the orifice, the hole, and then the release. And then FLACS models the release here. So when it's expanded to atmospheric pressure. New model, we add this part where we include the effect of air entrainment. And then you can start your leak here, which means that you get a bigger area and a lower velocity. So big area, lower velocity means you can use a bigger grid and you can use a larger time step. And that all means you get speed up. So typically 1.5 to 3 times speed up. And the results will be more or less the same as with the old leak model. It's important to realize that, so it's only being validated for gas releases at the moment. So you can't use it for kind of flashing releases. So you have to be careful with that. And it assumes, the assumption is that there's no geometry in the entrainment area. So in this area, the assumption is no geometry. I think the limit is about 5% blockage ratio. So you have to make sure that you don't have any geometry there. And it gives similar results, but not identical to using a normal leak. I'll just show you how this works. So what I'll do is I'll just set up a normal leak, and then I'll show an entrained leak. And then also show what happens when the geometry is too near your leak for the entrainment. Oh, some of the videos are... Yeah, it's playing, isn't it? Yeah, okay. So now I'm setting up a leak, just a normal, and I'm refining the leak like you're used to. Okay, so that's a normal leak. And now I'm going to show, okay, then I'll save it. Okay, and now I'm going to make an entrained leak. So the same geometry, go to leak. So then instead of jet, you choose entrained or entraining, and then it does the rest automatically. So it moves the leak to the right position, and then the refinement is different here. So you see, you don't need to refine here because you're using this entrained leak with a bigger area. Okay, I think so that's just setting it up. Yeah, okay, maybe I can just skip through this. Okay, well, I might as well just play it. Yeah, so here I'm making a third leak where I'm put the leak too close to the geometry. So this is an entrained leak with geometry in the entrainment area. So you shouldn't do this way. It's just to show what happens when you do this. Okay, so I'm saving on a new job number and I'm running them. I'll run them all three, and we'll see what happens. Okay, and then this is the output you get if you put your geometry too close to your entrained leak. This is yeah, you get this warning. So you have to, if you get that warning, you know what the problem is. But in general, this works really nicely, and then you can reduce calculation times by typically 1.5 to 3 times. Yeah, so this is just a video showing the difference in results. On the left time, this is the normal way, and this is with the entrained leak. And the same here above. See, so you see, yeah, there's slight differences, but in general, the results are the same, but you get the speed up. Some other improvements we did to the fire model. So we included a couple pool fires. So now the heat radiation from the pool fire is coupled back to the evaporation rate. So it accurately calculates the evaporation rate based on the pool fire. We've improved the conduction model. So that's if you have a jet fire, for example, and you have a wall, the temperature increase of the wall is now included. And we've improved the user manual, especially related to how to set the buffer for the radiation modeling. Yeah, I'll skip through this quickly, but we've changed the interface a little bit to setting the 3D variables. It's a little bit more intuitive now. So you basically move them between these two fields, and then you can select which ones you want to use. Yeah, I'll probably, I'll skip through this. Yeah, this is 3 isocontours. You can make these kind of plots when you do isosurface here. This is quite nice. You could use this to visualize LFL, UFL clouds in the same plot or different radiation levels. And this is really nice. These are 3D streamlines. This is a really good way to visualize flow in 3D. I'll just start the video. So we have choice. So you need to use the velocity vector. This is now showing glyphs, which are just arrows, 3D arrows, the results, and then you can change the size and, of them using control and plus or minus. I'll just you can kind of get the idea. But I'll go to the. These are the streamlines. These are really nice. So these are lines that follow the flow of the follow the stream. Sorry, it's a bit late. I'll just show what it does. So here you can see it really gives a good 3D representation of your flow. And here you can see what the reason is. You get this kind of cloud because you get this rotation of the flow here. So it's a really good way to visualize your flow. So for example, for ventilation or dispersion. Yeah, just really brief. So we're further improving the Python API. It is a work in process, so it's not finished, but it's really a tool for users to kind of post-process and set up geometry, etc. So it's potentially really nice. For CAS and FLACS, it works really well. Some of the pictures I showed in the my risk presentation, I kind of used some post-processing in the API. For Flow, it's very experimental, so yeah, just realize that. And the documentation is a little bit difficult to use. The best thing is to use the examples in the documentation. And I'll just show you where like how to run it. And so here you have this Python menu, and you can do open. So you open your Python file there, and then you do run. And what's important here, the API reference, that gives you the documentation on the Python. And you can also run it from a command line if you want, or from IDE. And so this is an example of the documentation. So this is the best way to figure out how to use it. And then we have a number of examples there. So for some cases, for manipulating grid or setting scenario parameters, etc. So this is an example of a geometry example. So instead of having to like output text files and reading macro files, you can manipulate geometry directly using this Python interface. Yeah, and this is an example for grid. And this is an example for batch outputting videos or pictures. I think I have a video of that. So, yeah, so now it's outputting. So I've made using a Python script to batch output videos. So that's what I'm doing here, and then you can see them being generated here. It works really well for pictures. For videos, you can't put the resolution too large. So it's, like I said, it's a bit work in progress, but potentially very powerful. And my computer is a bit slow. So, yeah. So here you see the videos being generated. Yeah, this is the release coming out in a few weeks. So we have an improvement in the modeling in FLACS Fire for conductive heat flux in the monitor points. We've basically changed one of the assumptions. The initial assumption was that a monitor point has a fixed temperature, which is the same as ambient. And that gave slightly conservative results for conductive heat flux. And now we've changed that, it actually changes temperature based on so it's more representative of a thermocouple in the flow, which actually heats up when there's fire. Yeah, and then other like minor bugs and improvements. And the release date I've set here, like November, December. I expect it probably at the end of this month. There'll be a new version. Right. Okay. So now that was a little bit about 10.4, and now we get to the fun part. Is is there any feedback from users? Do you have any issues or any bugs you would like to report? Are there any features you're missing? So I can put my microphone on, or speakers. Nobody? Everybody's really happy? Great.
I think with 2 days heavy meeting,
I'm sure that's it.
Tired.
Yeah. I mean, anything you can always use FLACS at Gexcon.com or contact my colleague Bing Xi if you have wishes or things you're struggling with or would like to change. I'll just. You have a wish? Great. Just a moment, I need to switch it on. Sorry, yes. You.
我想知道你们什么时候能推出中文版
See, there are requests. Yeah, it depends on what the need for that is. I don't know. But we'll write it down. Is it important to have a Chinese version? Is it important?
如果你想完全的进入中国市场，适应现在中国政府正在推行它更严格的安全制度。你想占领这块市场，我觉得中文版很重要，因为中国人的英语可能比起印度人、新加坡人都要差一些，但是它的市场比他们大得多。中国政府在天津爆炸之后，很多政策已经开始转向。我们的安全设计已经从以前的安全电锯开始变更为安全计算，而安全计算你们的软件很有竞争优势，但英文操作将是你们最大的障碍。
Okay. Well, yeah, we can look into that, I guess. I don't know if Eric, are you taking notes? One of the kind of intermediate versions is potentially making a Chinese, I don't know, manual or tutorial or something. That's it is quite a lot of work of changing the whole interface to Chinese. But we could maybe do something with documentation, and in future we could do something with language. It's a good question. I think everybody's. It's been a really nice 2 days, I think, and thank you very much for.
I will ask Stu to state something.
Perfect, great. Thank you very much.
Thank you.
Thank you very much for chairing.
Thank you.
Perfect job.
就是基本上到了最后环节了。最后环节的话呢，首先的话，我想的话，请 Stuler 先生的话呢，能够给我们说几句。他是这个 Gexcon 公司的这个总裁。Stuler, please.
Ladies and gentlemen, it has been a pleasure to be here through these 2 days. This is, as been told you before, the 26th FLUG meeting, and it's the first one in China and in Asia. I can promise you that this is not going to be the last, but I cannot promise you that this is going to happen every year. Because, as you know, Gexcon is working globally to prevent fatal large accidents to happen. And we are working then on a global scale to do that. And our mission here is, of course, to share our knowledge and our expertise and technology that we have built over 45 years with research and development in Gexcon. And through these days and the interaction that has been here is really impressive. I would thank you all for the participation, because it's not always that we see this involvement from the participant or the audience. And it is really valuable for us to have this interaction with you, because then we can learn from you and you can also understand the issues and get new knowledge that you can use in your daily work. So thank you again. And then, of course, I have to thank management at CCS for hosting this event, and also the staff who has been serving us and helping us to have a good time here in these facilities. And I will thank you all again for coming to this event and make it a success. And I wish you a safe trip home, and I hope to see you next time. And we will soon come back with some announcement about an ASEAN summit that we will hold next year here in China, which will be then for the region, to bring together the region to discuss some of the challenges that you have. As you know, Asia is going to be the most important growth region in the world, and in the next 2 decades, 70% of the gross production is going to be created in China, in Asia. So that's why it's important to focus on safety, to make sure that we can prevent these accidents to happen and have a good understanding and share the knowledge and technology. So thank you again, and I wish you a safe trip home, and thank you.
最后我还说2句 ，please stay here。首先来说的话呢，正如刚才最后这位先生说的，现在的话，中国的情况的话是在发生转变，特别是天津事故之后，那么这种基于量化的这样一种风险的评估的话，不管是在将来的这个事前还是事后调查的话，都会有广泛的应用。所以说这一块的话呢，应该来说的话，大家这样一个应用的话呢，从参加这个会的这个情况来看的话，我们就可以看出来。同时，作为 CCS 来说的话，我们想提供的是一个广泛的平台。刚才前面我说过了 ，CCS 的责任不光是一个classification 的责任，因为它前面还加了2个字是中国。所以说，我们有这个责任的话，把中国的这样一个事情办好。那么，这个中国的事情要办好的话，也是靠我们中国人大家共同来努力。当然，也要靠我们的朋友，来自全世界的。最后的话，还有一个比较遗憾的事情，就是这一次啊，我们大家的话，这一个场面的话，大家第一次在中国的话没有合影。那么现在有些朋友已经离开了，最后的话，我是不是建议我们大家都上来，在这儿能够有一个合影，好不好？欢迎大家。